Hello, good afternoon, everyone. For my presentation, it will be far less dangerous than the swag, so not worry. So, thank you all for having me. My name is Derick Chen. I'm a solutions architect with AWS Singapore. And today I want to share a little bit on how do we actually design and build microfrontends on AWS. So a little bit more about me. I'm currently working as a solutions architect. I'm a developer specialist in the DevX team, and I go around the region helping enterprises build softwares better, right? So my mission is to empower developers to build faster and better with what we call the adaptive systems design. And previously, I was a software engineer, so I'm really into software development, and this is why I want to do the work that I do today to help more people to build better and build faster. So to just have a very quick introduction of what we mean by adaptive systems design, the core principle is about having a nimble architecture that has least cost of future changes. If you think about your existing code bases, how many people, right, thinks that your current code base needs a refactor? And how many of you actually want to do the refactoring? All right, that's right? So, I mean, we are all, amazing developers. We follow the standards of what we consider as modern at different periods in time, and we create these wonderful applications. But eventually, over time, they become outdated. So my work today primarily revolves around how do we keep modern application modern. And microfrontend is actually a way to do this, right? So let's look into what we're going to talk about today. We're going to talk about what is microfrontend, so we all have a common understanding, and we're going to look at some very high-level benefits and trade-offs, and how we're actually going to design the microfrontend so we got the structure right before we actually delve into the implementation. And finally, I will show you some architecture sample diagrams of how you can deploy your microfrontend services on AWS. Okay, so what is microfrontend? But before that, let's look at something we're all very familiar. All right, who has built an app like this before? Right, if you have done like a side project or you have worked in an enterprise context, right? If you are on one team, you build a product internal facing for your internal stakeholders. Most likely, this is what your app look like. You have a front end that's built and deployed as one unit, and you have a backend service that has, probably a few different APIs to supply the data and to do some manipulation for the presentation layer. So, and if we go into micro front-end, what we're really talking about is an architectural style where independent deliverable front-end applications are composed into a greater whole. I really like this quote because the very last part, a greater whole, right? So in terms of micro front-end, the actual application is more than the sum of its parts. And it's also into a greater whole because at the same time we have these benefits, we also introduce some trade-offs that I will touch on later on. So how would it look like? So this is how a micro front-end application would look like, right? So we need some kind of container application still on the front end as sort of a container to house all our micro applications that will be independently deployed. And as you can see, we can use patterns such as a backend for front end, BFF, to manage, to have a dedicated endpoint for all our front end requests for each and every micro child application that we have. Now you might be wondering, why do I need to split my applications into all these different parts? The easiest answer is when the product grows, the natural complexity increases. And what do I mean by that? Have you ever heard of these things being thrown around in project meetings, in sprint planning? Right? These are the signs of what we call the big ball of mud. If you have been building microservices and you've seen monolithic applications, you know exactly what I talk about. If you are hearing these statements in your meeting, that means the application, the project is on fire. Things are burning in production, and you need to put out that fire before you can add any sort of innovation, new feature requests to it. And this is when businesses slow down to a grinding halt because we cannot effectively manage the complexities and technical debt at scale. Right, so how would Microfrontend help us with this? The core benefits can really be broken into two categories. So first of all, we have the speed. When we have smaller units of development and deployment, we tend to have shorter product lead time from an idea to an actual feature. This increases the release velocity of teams that are building the individual apps because you no longer have to wait for the dependencies that maybe is being held up by another team's release schedule. And of course, this enables developer collaboration across teams. Many people, you will basically step on each other's toes way less. You don't have to share so much code. And the nuggets of tribal knowledge within each of these subdomains are properly confined in the appropriate boundaries. And the other benefit will obviously be the shorter deployment pipeline. If you have automated testings, code scanning, end-to-end tests, that takes, the longest project I've seen run is 8 hours, all right? This is an actual production system that takes 8 hours for my feature to land into production. So with a micro front-end design, you should land your release way faster than that. And the other side of things is the quality that you can improve with your application. I noticed that we still do have some Angular developers here, so micro front-end does allow you to be a little bit more technologically agnostic, right? You can use different frameworks to build your mini applications and to house them together with the container application. And of course, this helps us to isolate our failures and have more predictability in our release cycles. But of course, it comes with its own set of trade-offs. The most obvious, I think, right, that you can think of right now is the deployment complexity. Originally, we just needed to maintain one deployment pipeline for the monolithic front end. And then now you have 3 different micro front ends. You need to separately build, manage the CI/CD pipelines to do the code scanning, functional tests, and everything. So it's definitely added complexity there. And as the natural next step, the integration of all these smaller micro front ends to make sure that all these apps work together is another big problem. And for this, you definitely need very comprehensive test coverage and end-to-end tests for this to work at scale. And the unique challenge when it comes to distributed front-end development is with the UI/UX consistency. When you have different people building different parts of the application, some people like to put a button on the left, some people like to put a button on the right, and maybe there's a different way that we phrase certain prompts. And all this need to be addressed to ensure that our users have a unique and coherent experience across the entire user journey. And the last technical trade-off will be the amount of data that will be needed to be transmitted to the client device will be slightly higher as well. So, right, it's all very nicely drawn, 3 big boxes, but in reality, how do you know where to draw these boxes? Right, you have a profile service front end that, okay, maybe I talk about, changing my password, updating my username or whatever. But if I want to say update my billing method, should that be part of the profile service front end or should that be part of the billing service front end? And these are the kind of questions that we should ask as developers because these are very integral into how we will implement our features next, where we will implement our features. So the methodology I like to use is called domain-driven design. Anyone heard of domain-driven design? Awesome, you guys are awesome. So it's nothing new. It's actually popular. It was created maybe about 10 years ago. But to utilize this in a methodology can help you arrive at the right boundaries where you divide your micro front-end applications very clearly based on the business domain. So for those of us who are not too familiar with domain-driven design, it basically is a process that aligns our code with the reality of your problem domain. Basically, it's saying that we should write our code based on the problem that we're solving for our end users. And this makes a lot of sense to me because after all, whether you write JavaScript, TypeScript, whether you use React or Angular, the technology is only a tool for us to deliver the business value. And if we start our application design from backwards, from what the value we are trying to create for our users, we can make sure that we don't put the cart before the horse. So at a very, very high level, we don't have too much time today, so I'm just going to go at a very high level. Domain-driven design focuses first on the strategic design, and then technical design, and finally translate that into software quality matrix. And how does that actually mean, right, in software engineering? So at a very high level, we want to follow the principles of high cohesion and low coupling. That means snippets of code that perform the same functions or mutates the same kind of objects and concepts should stay together. And at the same time, the separate units of deployment, the different micro front ends, should be loosely coupled. So if one of them fails for whatever reason, might be a botched update or an infra issue, it should not cascade and bring your entire application down. So that translates into our tactical design, which the most important piece will be the independent deployability. We want our micro front-end applications to be independently deployable. That means if my profile service receives a release tomorrow, I should not need to rebuild all the other micro front ends in order for my application to be updated to be displayed to the front end users. And all this will be measured with the DORA matrix. Of course, in your project or in your team, you may use more specific to your business matrix to also measure the effectiveness of your software. And to put this into practice, we use a method called event storming. So basically, we get everybody into the room, right, the business team and the technical team, to figure out what exactly we are building. Because when I was a software engineer, a lot of times I only know the modules that I'm working on myself. For example, if I'm working on the profile services, I have no clue how they integrate with the payment gateways. So we have all these silos and we have these nuggets of tribal knowledge spread around different parts of the team. And the first step is to get everybody into the room to sit down and use this methodology called event storming to try to piece out what exactly is the problem we're solving and how we're solving it. And once we determine that, we can use some heuristics to draw the bounded context in domain-driven design in order to establish a correct boundary for our micro frontends. Now, if we want to talk about how to actually build micro frontend that can be stitched together in a parent application, including using different JavaScript frameworks, we need Modu Federation. So Modu Federation is a native plugin for Webpack 5. It acts sort of like a container and enables the sharing of JS code between front-end apps at runtime. So the key thing to take note here is that this allows the code sharing at runtime, not at build time. So to continue to use my example previously, we have a container application that will act as, you can think of the house of the micro frontends, and we may have micro frontend A and micro frontend B written in different frameworks. But that's fine, because for Modu Federation to work, all we need to do is to expose the modular application, and then we will link these modular applications in the container, and then finally just simply import the components in the container application. So very simply, right, you can just expose the Angular app that we have right now with the Modu Federation plugin, and then we'll declare the remote of our micro front end in the container application. And the final step is just to import it and load it in React. So now you have your Angular application running inside a React container for your micro front ends. Okay, so now we have built the micro front, but how do we actually deploy it, and what are the best ways to deploy so that teams can collaborate? One way to do this is to have a dedicated infrastructure environment for each of the teams building a micro front end. Now, this architecture is not optimized for cost, but this is optimized for collaboration and productivity. Right? So this, you can see clearly that we have this trade-off that we mentioned earlier. Now we suddenly have 4 different AWS accounts that you will need, and inside each of it, we will deploy one of our micro front ends, and we'll have to manage the CI/CD pipeline within each of these applications, there will be some repeated and unnecessary housekeeping that will be required, that could be shared, but this is still required. So we're going to have our CI/CD pipeline to do to get a repository from the source code, and then we're going to trigger the build cycle to build your npm build and do your necessary testings in AWS code deploy. You can run stages such as build test, push to an UAT environment, run your end-to-end tests, do the code scanning, and then finally, once the artifacts are of good quality, you push it to S3, and then you host it on the Amazon CloudFront, which is the content distribution network. So what the greatest benefit here is that each of these teams managing one of these microfrontends no longer have to wait for the release cycle of another team, right? Some companies, they run like monthly release cycles at the end of every month there's a code freeze, right? Nobody can check in any code. All the testers are super busy. They are running all the manual tests and hoping and waiting for that moment that everything's green and then deploy it. We no longer have to do that. Whenever your code is ready, you can release it to the environment and you'll go through all the automated tests, and immediately the parent application will be able to pick up the latest version of your application. And that just tremendously decrease the amount of time that it takes to release applications in this manner. So the next question is, how do we actually get people to come together and build something like this? You cannot have how we traditionally have our engineers separated into different departments, all the back-end engineers into one department, all the front-end developers into one team, and all the DBAs, DevOps, whatever. No, that would not work. What we need is stream-aligned teams. So every vertical that you see, all the blue boxes, are a team responsible for one particular microfrontend application. So inside these teams, you will need a myriad of different skill sets, a mix of different kind of personas, so that you have a cohesive people unit that can come together and quickly make decisions and execute and implement these applications. In Amazon, we call this the two-pizza team. That means if any team cannot be fed by 2 pizzas at a party, it's too big. So usually we recommend the team size between 8 to 12 developers. And sometimes we also have designers, business analysts, product managers, and so on. So a few other technology that would be also interesting include the ones to help with server-side rendering will be AWS Amplify, server-side rendering. This is a managed solution. If you are using AWS Amplify to host your application, this will be available for Next.js 12 or later. And otherwise, you can host your own UI composer with a containerized solution on AWS Fargate. And for service discovery, you can use AWS Cloud Map to sort of act as a register to keep a record of where all your cloud services are, where all the different components are. And then this also helps you to perform constant health checks. And lastly, AWS Systems Manager is also something similar, where you can abstract the actual resource and put them into something that's easily imported in the source code. So once you have this, you do not actually need to change the endpoints inside your application at a source code level if you need to switch your, say, for example, your API in a blue-green deployment. And the result is we want to produce these microfrontend chunks that the parent application can easily consume at runtime to enable frequent, fast, and small releases. And if all of these are of interest to you, our team has released a sample on GitHub. You can take a picture, or you can check it out with the QR code. And some of the snippets of source code I've shared earlier also came from this repository. So that comes to the end of my presentation. I hope that gives you some very high-level ideas about microfrontends. And there is a QR code on the right side, and if you can scan the QR code and give me some feedback on my presentation, you actually stand a chance to win USD $50 AWS vouchers that will not be flown to you. Thank you very much.